So you look at polynomials. So we did a sample of polynomials where we're looking at the methods of divisions. Methods of division. The first one being long division. We'll go straight into examples. Use long division to express the following in the form x minus k qx plus r of x, where x minus k is the divisor, q the quotient, and r the remainder. A, you divide x to the power 3 plus 2x squared minus 4x plus 3 by x minus 1. B, you divide 4x power 4 minus 1 by 2x plus 1. Solution. For the first one, we put x minus 1 here and then draw this, whose x3 plus 2x squared minus 4x plus 3 is the dividend. And then now I start dividing. What is x to the power 3 divided by x outside? So what you're doing here is you're looking at the highest degree outside and the highest degree inside. And then you divide the highest degree inside by the highest degree outside. So say x to the power 3 divided by x, which is outside. So we'll get x squared. And then you multiply now x squared by the whole divisor. So x squared times x, we get x3. And then x squared times -1, we get negative x squared. And then I can put 0x plus 0 to avoid any possible error, and then subtract this whole thing from the dividend. So now we say x3 minus x3, that is 0. Then 2x squared minus x squared. So we get a positive 3x squared, and then minus 4x plus 3. Then we divide again. 3x squared divided by x, the very x that we are dividing in the first place. So we get plus 3x. Again, multiply, we have 3x squared minus 3x, and then plus a 0. Subtract, put it down, so we get 0 there. Negative 4x minus, that is negative x plus a 3. Then a negative x divided by x, we get -1, and then multiply, we have negative x plus 1. Subtract again, we get 0, 3 minus 1, we get 2. This means that the quotient is the one that we have up here, x squared plus 3x minus 1. The remainder is this number that we have down here, which is 2. And then we now write the expression, therefore, x3, the whole question, plus 2x squared minus 4x plus 3 can be written as, in the required form, x minus k, that is x minus 1, multiplied by qx. Qx is x squared plus 3x minus 1 plus the remainder, which is 2. So this can actually help you check if what you're putting is correct. You can quickly do the multiplication and see if you still get the question. So if you do that, x times x, we'll have x3, and then we'll have 3x squared, and then we'll have minus x squared minus 3x plus 1 plus 2. So if we add those, we get x3 and then plus 2x squared and then minus 4x and then plus 3, which is our question. This was just to check. This was verification. This is option. If you're not sure, I can check. If you're sure, you move on. There's no checking. Okay, then we do the next one. B, we put 2x. This was 2x plus 1 plus 1. And then put 4x4 plus 0x3 plus 0x squared plus 0x plus, is it plus or minus? I think it was minus. Minus 1. Minus 1. So what I'm doing to the polynomial 4x squared, 4x4 minus 1 is, because I've noticed that some powers are missing and I'm trying to avoid all possible errors, so I'll put zeros to represent those missing powers. Then now I start dividing. 4x4 divided by 2x. Here we get 2x power 3. Then you multiply, we get 4x4 plus 2x3 plus 0x squared plus 0x plus 0. And then I subtract. By the whole thing, I'm getting 0, and then minus 2x3, and then minus 0x squared, and then minus 0x, and then minus 1. Minus 1 coming from up, because minus 1 minus 0, I get minus 1. Then divide again, negative 2x3 divided by 2x, we get negative x squared, multiply, negative 2x3, negative x squared, now plus 0x, now plus 0. Again, subtract. So negative 2x3 minus minus, that's 0. Then 0x squared minus x squared, so get positive x squared. And then negative 0x minus 0x, we get another 0x. And then minus 1 minus 0, we get minus 1. Then now we divide again. X squared divided by 2x. We get plus x over 2. Then multiply. We'll get x squared plus x over 2 0. We subtract, we get 0. We get negative x over 2 minus 1. Divide again. So now we're dividing x over 2 negative divided by 2x. This is the same thing as negative x over 2 multiplied by 1 over 2x. So the x's will cancel and they remain with negative 1 over 4. So we're taking minus 1 over 4 and then multiply. So we'll have minus x. Multiplication there we have 2x multiplied by negative 1 over 4. That's going to be negative x over 2. So you have negative x over 2 and then minus 1 over 4. Subtract, we get 0 and then minus 1 minus minus. That's the same as minus 1 plus 1 over 4. So this is negative 4 plus 1 over 4, giving us negative 3 over 4. So writing in the asked order, you have the polynomial we have the polynomial 4x4 minus 1 is equal to 2x plus 1 multiplied by the quotient 2x3 minus x squared plus x over 2 minus 1 over 4 minus 3 over 4. Like that. The last one being the remainder.
So is there any other method of calculating this one without showing the missing powers?
And you're using long division.
Yes.
Except where we just say I can do it without the zeros. You can still do it without the zeros.
Can you kindly do it for us, sir?
Same method, the same long division. You can just, as long as you're careful with the signs, because you put 2x plus 1 and then 4x4 minus 1. Then you start 4x4 divided by 2x, you get 2x3. Then multiply, you get 4x4 plus 2x3. Then you subtract. So you know there's no x3, so when I subtract here, I will just get negative 2x3 minus 1. And then divide, you get minus x squared, multiply negative 2x3 minus x squared. Subtract again, you get a 0 on the first one, and then you get x squared minus 1. Then divide, that's how you get now x over 2. Multiply, you get x squared plus x over 2. Subtract, the first one 0, then again you have minus x over 2 minus 1. Then divide, you get minus 1 over 4. Multiply, you have minus x over 2 minus 1 over 4. Subtract again. Then you get negative 3 over 4. And you're done. So I haven't put the zeros, but I was still able to get the solution. So, but it's advisable to put the zeros because if you haven't done enough practice, you get lost there. Okay, then the same question, we now use synthetic. Synthetic, what we have as a divisor is, first the question is 4x4 minus 1 divided by 2x plus 1. So this is your target when you're using synthetic. You equate it to 0, 2x plus 1 equal to 0, and obtain x. So x is negative half. This is the one that we write first. And then block down here. Then you go and look for the coefficients of the polynomial. Now that it becomes important that you operate with all the coefficients. For the highest degree, we have 4. Then we're supposed to have x3. Then we're supposed to have x2. Then we're supposed to have x. And then that's when you go to the constant negative 1. Then drop the first number, 4. And then I'll start multiplying the number outside by the numbers that will be coming down here. Okay, so we'll multiply negative half times 4, we'll get negative 2. And then add now, we get negative 2. Negative half times negative 2, we get positive 1. Add, we get positive 1. Negative half times 1, we get negative half. We add, we get negative half. And then this will give us 1 over 4. We add, we get negative 3 over 4. The last number becomes the remainder. So this is the remainder. So the last number becomes the remainder. And then since the power was 4, the quotient, which we form from these numbers, still comes from these numbers now as 4x3. So the power reduces by 1. And then minus 2x squared plus x minus 1 over 2. The remainder, we said, is negative 3 over 4. And this is the most used method in so many questions. Slowly. The results are not good so far. I don't know what you are doing. But a few I know, so far so good. So I think this way they'll keep you very busy. I'll start assessing you now, so that I don't get shocked. Then a simple application question. It's a polynomial. Given that x minus k is a factor of p of x is equal to k x to the power 3 minus 3x squared minus 5kx minus 9. And k is a real number. Find the possible values of k. Hence, solve px is equal to 0. This is a very simple question. Given that x minus k is a factor, so now we get back and define what a factor is. If the remainder here is 0, then you say the divisor is a factor. This is the divisor. So we're saying if the remainder is 0, then the divisor is a factor. So stop. Second, if x is equal to a is a factor, then f of a is equal to 0. 3, if x is equal to a is not a factor, then f of a is equal to k is the remainder. So if x is equal to a is not a factor, then when you pick a and take it in the function f, you get the remainder. So if you put the value k, then that value becomes the remainder. So that if I'm given the remainder, then you know that, okay, because I'm given the remainder, then this means that if I get the divisor given and substitute in the function, I should equal the remainder. Solution. Given that x minus k is a factor, meaning that if we get x minus k and equate it to 0, then we'll have x is equal to k. We are told this is a factor, this polynomial, then p of k should be equal to 0, implying that where there is x in the polynomial, we'll substitute k minus 3k squared minus 5 minus 5k k minus 9 is equal to 0. So whenever there is x, we take k because we have found that x is equal to k. is what we get after equating x minus k to 0. And we are told that x is equal to k is a factor. So that's what we do there. Getting from this definition here of a factor equal to 0. And then this means that we now have k to the power 4 minus, this is 5k squared. This is 3k squared. So we add this and get 8k squared minus 9 is equal to 0. Wow, this looks like something complicated. But it's just a quadratic. If you let a y be equal to k squared, then we'll have y squared minus 8y minus 9 is 0. And then we'll get y squared. But the factors there, we can use positive 1 and minus 9. So that we get y plus 1 minus 9, y plus 1 is 0. So y is equal to negative 1, or y is equal to 9. So we're saying k squared is equal to negative 1 is not possible. So k squared is equal to 9, implying that k is equal to plus or minus 3. This is possible. To answer the next question, hence solve px, you pick just one value at a time. So if k is equal to 3, then you substitute in the polynomial. So you have p of x is equal to 3x to the power 3 minus 3x squared. And then this is k, which is 3. So 3 times 5, we get 15. So we'll have minus 15x minus 9. We haven't forgotten that x here is equal to k is a factor. So x is equal to, we have used 3. 3 is a factor. So we can use a very one. Synthetic, I will just correct the coefficients. Negative 15, negative 9. And then place down, we get 9 if you multiply. When we add, we get 6. Multiply, we get 18. You add, we get 3. Multiply, we get 9. So we get 0. So if we get 0, it's okay. It confirms that our answer k is correct because we're even getting 0 as a remainder. So it is a factor. And then now you can say, so px is equal to x minus 3 and 3x squared plus 6x plus 3 is equal to 0. We're now solving this equation. Meaning x is equal to 3, and then the other one, x squared plus 2x plus 1 is equal to 0. This means that we get x plus 1 is 0, and the other x plus 1 is 0, so that x is equal to negative 1. And x is equal to 3. Are the factors when you use k is equal to 3. You can as well use k is equal to negative 3. It will land you on some things. I hope you're able to connect. Yeah. So you try as well.
How
Yes.
did you reduce the k squared? The k squared from k to the power 4. I'm very much behind on that one.
So we let a random variable y check k squared, so that if you square y, then you get k4. Then you substitute here. Then you make it a quadratic. That should be question 2 of sheet 4. I've done much of that in there, where you make something that looks like a very big complicated polynomial into a quadratic. So that's how you do that one. So I want you to solve this one. You're using k is equal to -3. And tell me when what you get when we join again. So this is 2045. Okay, 15 minutes. Yeah, 10. So at 55. Yeah, at 55. Should be joining back. Should have tried to solve this so that you tell us what you will get.
Sir,
Yes.
where do we put the same -3?
Well, we have put 3 in the actual polynomial p. Here where there is a k, that's why I put -3. And then
Okay, thank you.
the same one will apply here, meaning it sounds like you're going to use here as a fact. And then make out the polynomial.